For this session on application of image processing, we have with us Dr. O. Uma Maheswari Madam, Professor, Department of ECE, College of Engineering, Anna University, Chennai. Ma'am has more than 20 years of experience in teaching and research. Ma'am did a BE in Electronics and Communication Engineering from Tyagarajar College of Engineering, Madurai Kamarajar University, ME in Communication System from Madurai Kamarajar University, PhD in Digital Signal Processing from Faculty of Information and Communication Engineering, College of Engineering, Anna University, and the title New Median Algorithms for Image Denoising and Impulse Noise Removal in Speech Signal with Reduced Jitter. Ma'am's area of specialization are non-linear signal processing, analysis of MRI, enhancing the underwater images. She is a senior IEEE member and life member in Computer Society of India. Ma'am was appointed as lecturer in 2003 in Anna University and professor since 2017. Number of PhD scholars guided are 7, and at present Ma'am is guiding 3 scholars, and ME MTech projects guided are 95. Ma'am has many journals published, papers published in international journals 20, international programs 11, national programs 14, and articles 2. A sponsored project of rupees 6 lakh is optimum design of reflector array antennas for mobile satellite station funded by DST Government of India. And she has visited National University of Singapore, and she served as professor and nodal officer for SAST Cell, Anna University, Chennai, and Senate member for IIIT Trichy since 2019. We are happy to have you with us, ma'am. I now invite our Deputy Director, Madam, CFR, Dr. Soundar Naiki, ma'am, to felicitate Professor. As a token of love and appreciation, kindly accept it, ma'am. Thank you, ma'am. Over to you, ma'am.
Good afternoon. I first place my sincere thanks to the Director Center for Research for giving me an opportunity to be part of this orientation program. As a teacher, it's always tough to have a class in the afternoon. That too after a very good lunch. But I think I'm not going to give a very technical content in deep in such a way that I won't make you sleep. That guarantee I can give you. Title which was given to me is Image Processing and its Application in Scientific Research. That was the title given to me. I thought I can give an overview about the image processing and what are the current scenario or what are the current research going on in various fields pertaining to image processing. That was an objective, that was an idea which I'm going to give you in today's session. So I placed my agenda in this way. So little bit of applications related to image processing in the various fields and some of the vendors or organizations who are working in the field of image processing so that you can get an idea about what are the works currently going on, where we can fit in, and various tools related to image processing. That gives an idea about what are the tools that we can currently using or what we can use in related to our research work. And always we should give a credit to the researcher, eminent people who have worked, who have contributed in the area which we are working. As a researcher, as an academician, we should give a credit to the researcher or our forefathers who have worked in the area of which we are working. So eminent researcher in the field of image processing. I particularly placed this slide in order to give 2 insights. One is who are all working in the area of image processing. That's one thing. And the second point, whom we can get in touch with related to our research work or related to the work which we are going to, or to some of the ideas or some of the clarification to whom we can contact. For that, I have placed the slides, only 2 or 3 slides related to eminent researcher in the field of image processing. And the current trends which is happening in the image processing. With that, I'll finish my presentation in less than 1.5 hours. So, as I said, I am here because of my professor, Dr. D. Ebenezer, who is my supervisor, who taught me in the area of signal processing. Because of him, I got my PhD in 2009 in the area of nonlinear signal processing. So first I place my thanks and I owe to him. I dedicate this presentation to him. So this is one thing. Second thing, this digital image processing, I got into this digital image processing. The very first book I read in related to the digital image processing is 1996 while I'm doing my BE. That book was written by Rafael Gonzalez. This digital image processing by Rafael Gonzalez. I hope everyone would have heard who are working in the field of image processing. So he's one person who made me, who taught me various aspects of image processing. And the second person is Anil K. Jain, A.K. Jain. He is an Indian American. So these two authors, they have written a book in digital image processing, and I gained a lot of knowledge through their books. So we come into the actual session. Whatever the presentation we start with, we usually start with the definition, right? Whatever it is, whatever the very first word comes, we actually start with the definition. So obviously I too start with the definition. Digital image processing. We all know what is digital. Digital is obviously in terms of time and the amplitude, both in the way it has to be in digital. That is one point. Image processing. Obviously processing the image. What is the image? The image is a two-dimensional thing. If it is the signal, we are going to talk in terms of one-dimensional. If it is the image, we are going to talk in terms of the two-dimensional thing. So digital image processing, which is digital, which is two-dimensional, which is going to be a process. That's the thing we are going to talk about. So a digital image is an image f of x comma y, which been digitized in both the spatial coordinates and as well as the brightness. For f of x comma y, we denoted the value at f of x comma y, we call it as the gray level or the pixel value or the brightness, and x comma y is the coordinate. That's it. So if you see the image, the actual image, which been acquired by the camera, how it been represented. This is the digital image. That's it. And what are the formats or what are the different ways we can represent or we can have the look into the images? One is we can have a black and white image, which we represent by one bit, either a black or a white pixel, or we can represent it a grayscale. Grayscale have distinguished color which lies between white to black. And another one is color image, where the color image we can represent the color image by three samples per point. One x comma y, one coordinate we represent by 3 points. One represent R red, another is green, another was a blue. This we can look into it by seeing this one. The portion highlighted in the baby image, the value of that particular portion is represented in pixel values in the highlighted region. If you see that, the values between from 0 to 255. So we are representing from white to black, which lies between 0 to 55. So you can see the pixel values lies between 0 to 55. That represents the grayscale image. In the right hand side, you can see a color image where that color image is formed by combination of R, G and blue. So R color plane that have a value which lies between 0 to 255, R, G and B. So if we take a grayscale, we can represent the grayscale by 8 bits, whereas in the color image, we have to represent one pixel at 8 into 3, which combination of R, G and blue. So storing the grayscale image, storing the color image, that varies. For example, if we take a 4x4 image, 4x4, so the total pixel is 16 pixels. Each pixel is represented by 2 bits. If we approximately take 2, roughly, each pixel is represented by 2 bits. In that case, representing the 16 pixel requires only 32 bits in the grayscale image. If it is the color image, the same thing. If it is a 4x4, if we represent each plane by 2 bits, to represent one pixel, we need 6 bits. So the number required to store the color image, if we take, it's 16 into 6. That number of bits is required to store. So storing the grayscale and storing the color image, that varies. So what are the different modalities by which the image being captured, and what are the characteristics if various modalities if we go with? That is shown in this slide. The very first top left shows the gamma ray imaging. Gamma ray imaging. The middle image shows the chest X-ray image, and the top right shows the head CT image, computer tomography. And the bottom left shows the aortic angiogram, and the middle is the ultrasound, and the bottom right is the thermal images. Each modality gives the different features or different textures or different information about the images. If we take the CT and the MRI, CT and the MRI, this one is the MRI, this one is the CT. The CT and MRI, for brain images if we take, one gives the information about the soft tissue and one gives the information about the hard tissue. So the different modalities gives the different information about the actual scenario. For example, we all know and we are expert in taking the selfie. If I take the selfie in the right side, I get some information. If I take the selfie from my left side, there's some other information. If I take the selfie from directly, there is some other information. So viewing it in a different direction gives the different information. If we possible to combine the entire thing, that the fusion, the image fusion, if we try to combine the image fusion or if we try to combine the various image modalities, that gives an extra information about the images or extra information about particular application which we are working. So these are all 2D. Whatever the picture talks here is 2D. The MRI is 3D. Magnetic resonance images is the 3D images. That is the spatial. Apart from the spatial coordinates, if we take the sequences of images of the brain. So it's a 3D images. The next one is the functional MRI. fMRI stands for functional MRI. This functional MRI is the 4-dimensional data. Apart from the sequences, we include X, Y, Z, we include the time series too. So it's a 4-dimensional data. So working with the 2-dimensional data, working with the 3-dimensional data, working with the 4-dimensional data, that again a task. How we are going to work with, what algorithm we are going to work with. Are we going to work we are going to work for reducing the number of bits, reducing the storage capacity, or enhancing the quality of the images? That are all the open to the researchers. As I said, functional MRI is the 4-dimensional data. Apart from the X, Y, Z, the time series data is also taken. Obviously, as we are a researcher, we always begin with the literature survey. What for we are so particular about literature survey? The point number 1, the research topic which we have chosen, who are all worked, what are all the techniques they have invented, what are the limitations in their algorithms, to how extent they have gone in their research work. If we know all these things, then formulating our research problem and working on it will be easier. So always we start with the literature survey. So in such a way that to give a introduction about how the images would have been taken in a very, very first. Now we are taking a photo with our cell phone, which has a very, very high resolution, 128 pixels. We are having a very high resolution, 128 megapixels, all those things we are having. The very first image, which has been taken for 8 hours, that been named as the view from the window at Lee Grass, taken in US. That was the first photo taken in the year 1826, and it's been taken by Mies von Neeps. He used lithography. He took this photograph through this farmhouse at the outside of the window. The top left, that photo been captured for 8 hours to depict this. That was the very first photo viewed as the view from the window at Lee Grass in the US. in 1820s. Can you imagine what kind of the technique those time they would have at that time, and what the current scenario is? So the drastic change, the drastic evolution had happened because of the researcher who have been working in the area of image processing. The second one is 1921. It's been sent between London to New York, submarine cable, through submarine cable. It's been transmitted from London to New York, if I remember properly. So it's used a part plane cable picture transmission 1921. Later, the quality of the image is improved. Yeah, this one in 1922, where the number of tone, the telegraphy, where the tone has been increased in the improved digital image, and as well as the early 15 tone digital image. So you can see the quality little bit improved. The bottom one is the first picture of moon by Ranger, which been taken on 7th on 1961, Ranger 7 on July 31st, 1961. So if we can visualize from these kind of images to presently, we would able to visualize the images in the undersea bed. The quality of the images, the videos has been improved a lot. And as well as this, the image processing extended apart from the photography to the medical images. This image is, it's been 1979. The digital image processing being used in medical applications also. Now we are using the image processing in all the fields, So the use of digital image processing technique has exploded, and they are now used for all kind of tasks in all kind of areas. Image enhancement restoration, artistic effects, medical visualization, industrial inspection, law enforcement, human-computer interfaces. So I have just given few things which comprises all the fields. As we know that whatever we are working with, the images falls on the visible spectrum, which lies between 400 to 720 nanometers, from red to green. So some of the image file formats, I think most of you have come across a few of the things which has been listed in the slide. How the image is being stored, what format it been stored. These are some of the file formats which been stored the images, and especially for the medical images, which been in three-dimensional and more than huge volume data being stored in DICOM and NII files. Okay, how we can view the image processing collectively, how we can visualize or how we can view the digital image processing. What actually the digital image processing will do? It will do only three things. One is, it will enhance the quality of the image, or it will make more appealing to our visual perception. So the one task is, it gives more appealing about the images. That's one task. The another task is, we can try to get some information from the images. We can try to get some information from the images. That's interpretation or deduction or identification or classification that we can do. That is second thing. And the third thing, how we can store the compression. How minimum bits can be used in order to store the voluminous data. How we can store, or how we can use for further analysis. So these three tasks only the digital image processing entirely we have. So it's been improvement of pictorial information for human interpretation, or processing of image data for storage, transmission and representation for autonomous machine perception. This is the task the digital image processing focuses on. So some argument about where image processing ends and fields such as image analysis and computer vision starts. In that case, we can split these, what are the tasks I mentioned before, can be split up into three levels. One is low level process, mid-level process, and high-level process. If you take the low-level process, the input will be an image, the output will also be an image. For example, if image been corrupted by the noise, then noise, if we try to remove, then the output is the noise-free image. So input is image, output is a noise-free image. Again, if the input is not a good quality image, I apply some algorithm in such a way that quality of the image is enhanced. So input is an image, output is also image. In some time, if you take the old movies, we can see some scratches or some line kind of thing which come across. So if you try to work on that called as the restoration. So if you try to work on that, and if you restore, then again the input is an image, output is an image. So these processes all are low level process where the input is an image, output is an image. And the mid level process where the input is output of the low level process and output is the attributes. Output is attributes. For example, object recognition and segmentation. For example, if I, in my tidying table, if I place a basket where the basket contains fruits, various fruits. So, for example, the basket contains apple, orange, pomegranate, banana, and pineapple. Can you say what are the fruits in order to ensure that you people are not sleeping? Yeah. So the basket contains apple, orange, pomegranate, banana, and pineapple. So I want to distinguish between apple and banana. Is it easy or not? I want to, through our eyes, it's easy for us to segregate what is apple and what is banana. If it is to the system, segregating apple and banana, only one feature is enough, right? Only one feature is enough. What might be that feature is? Any idea? Color. The color is enough. And another one is shape is enough. So either the color that differentiate or either a shape that differentiate. So only one feature is enough to separate apple and the banana. Next the question comes. How to separate apple and the pomegranate? Now the task is little bit improved. Is it enough to segregate apple and the pomegranate with one feature? Is color can be used in order to separate apple and the pomegranate? Obviously no. In that case, what else can be added with? What else can be added with? Shape can be added, one thing. And apart from it? What ma? Size. Okay. Then texture. Then, so the point here which I want to convey is two distinguished objects can be identified by having only one feature. So distinguished object can be differentiated with one feature, whereas if we have two things which is little bit similar over other thing, we need more number of features to differentiate or segregate. That's the point I want to tell it. Where we use his is, if you want to classify the face recognition, or if you want to come out with the expression, face expression. So there we want to use more number of features in order to get the accuracy related to our work. That's the point I want to say. So mid-level process, the input is an image, the output is an attributes. The third one is the high-level process. The output of the mid-level is going to be an input and the output is the understanding. So feature is given and the classifier will be done. How the accuracy about the classifier? Is it done properly? Is the segmentation done properly? Have we obtained the output properly? That kind of the classification, that kind of the understanding is the high-level process. For example, screen understanding and autonomous navigation. So these are all the high-level process. So again, I compressed the entire thing in the systematic block diagram. I said low-level process, mid-level process, and high-level process. The same thing is represented in a systematic diagram. It's another version of what I have said previously. The basic block is the input image acquisition and the pre-processing. The pre-processing can be a low-level process or it can be a mid-level process. Next, the segmentation, representation, description, recognition and understanding, and the result. In the center, there is a block which talks about the knowledge base, image transform, image compression, image encoding. These are all used for different application for which we are performing. What kind of the application we are going or we are using that images. I said noise removal, which is the low level process where the input is an image, output is again an image. This is one example. Here, the left hand side is the noisy image and the right hand side is the noise free images. This right hand side image is obtained by applying a suitable filter. By applying the suitable filter over the noisy image. That suitable filter is an objective. What is the suitable filter? That's the question. To apply the suitable filter, we should know the knowledge about what noise is contaminated. That's the first question. Second question, intensity or the variance of the noise. How dense or what's the variance of the noise? If these two things is known, we can use the proper filter in order to remove the noise. So there the researcher can do many wonders. So we have to analyze the noise. We have to know the statistical characteristics about the noise because noise is random. Noise is random. So in order to analyze the random noise, we should know statistical characteristics about the noise. If we know the statistical characteristics about the noise, then we can use the proper filter and we can remove the noise in the images and noise-free image can be obtained. This is one thing. And the second one is, as I said, enhancement. Enhancement is how better we are making the image for human perception. How better we are visualizing, how better we are viewing the image. So you can see the left-hand side, you can see the difference between the left-hand side and the right-hand side. Left-hand side is the actual image, the right-hand side is the enhancement algorithm applied over the images and we have enhanced the image. Enhancement algorithm, I'm not going to talk about the techniques or the algorithm, what actually do. That's all, who are working, you will go and do it. This is an enhancement algorithm we can propose, we can use, there are n number of enhancement algorithm we can apply or we can create our own algorithm in such a way that we can enhance the actual image. That's the thing. The next one is the restoration. You can see the image in the left. I have taken this images from the net. The left hand side, the image, you can see there are some of the information about the image is being missing, where in the right hand side, the image is perfectly restored. This one is restoration. Earlier what we saw was enhancement. The enhancement is the actual picture. We just try to make it more appealing to our visual perception. Whereas in the restoration, some of the information being missed, some of the information being destroyed, some of the information are unknown. So, according to the knowledge we acquire, it can be a little bit of knowledge about the images or no knowledge about the images or entire knowledge about the images, we try to restore the images. So, restoration is again one area which we can work. And the next one is the object detection. High-level process, in the high-level process we saw autonomous navigation, autonomous vehicle detection, navigation, all those things. We can do the object detection. Where we use this object detection, what kind of the traffic flow, what are the vehicle is going on, is any intruder is there, all those things we can try to find it out by using the object detection. Here I summarize, this table gives the summarize the application and as well as the areas or algorithm which been used. If you take, we can use for all, you don't need to map the right hand side and the left hand side. Left hand side gives the areas and the right hand side gives the algorithms. Any algorithm can be mapped to any of the areas too. I have listed, don't just link the straight away, you don't link it. So these are all the algorithms which we can use. For example, artificial intelligence, AI, deep learning, neural networks, convolutional neural networks. That's the current topic. If you take any of the research paper current now, you can see AI in the front or AI in the end. So artificial neural networks or deep learning or convolutional neural networks, which we will use for the huge number of data, for the classification, for identification, for all those things, we are going for AI and DL. which we can use this for any areas which we are working. Next, the image segmentation, object detection, image representation, computer vision, image sequences, image coding. Image coding, particularly image coding, we try to use in compression, image compression. How effectively we can code the image in such a way that the number of bits used to represent the image can be reduced so that the storage capacity can be minimized. So effectively, if we code the image, thereby we can reduce the storage size. So image classification, image reconstruction, image resolution, feature extraction. In the feature extraction, as I said, two distinguished objects can be classified very easily. So similar object, if you want to go for the classification, more number of features has to be used. More number of features has to be used. Here comes the optimization technique. For example, as we start with the differentiating apple and the pomegranate. We started with the apple and the pomegranate. What are the features that can differentiate apple and the pomegranate? You have said few things, right? The color, texture, the size, all those things. In all these features, according to you, which one is the predominant feature, or which one gives the participate in the results close to or more than 50%? What might be that feature is? Obviously, there will be one or two feature which is predominantly contributing in order to classify between apple and the pomegranate, right? That features how we try to, we say the texture, or we say the color, or we can say the size, whatever it is. Each one have little bit of weight over the apple, right? So what feature majorly contribute for the classification? That if we try to analyze, that is the optimization technique. Which feature predominantly play to get the output, predominantly get the output in a very efficient way, the efficiency being increased. There we can use optimization technique. For example, there are 10 to 15 features are there for classification. 10 to 15 features, instead of giving equal weightage to all the features, we can give different weights to different features in such a way that efficiency of the classification can be achieved. So how different weights we have to give for the different features, that we can choose by using any of the optimization techniques. If we list down the optimization techniques, most of the research, most of the algorithms been derived or been implemented, which we are coming across in our life, which we are viewing in our life, which we are coming across, which we are familiarized with. For example, if we go to a market, or I think market, you people don't go, right? Shall I make it as a shopping? Yeah. So all are shaking their head. So I make it as a shopping. Taking a kurta fits for both male and the female. So taking a kurta, options are, I go to Reliance Digital Trends, I go to Pantaloons, I go to Max, I go to Zudio, I go to Saravana stores. These are the 5 options. What will be your first choice? To be honest, what would be your first choice? Trends. Okay. Is there any other answer? Saravana stores. So there, if my budget is limited, the choice is Saravana stores. If my budget is not limited, and wearing a kurta for what occasion? That also matters. If I wear the kurta for a normal day, wearing a kurta for a wedding, that differs. For the normal day, I can take a kurta in Saravana stores. For wearing in a wedding, I have to go for the trends or Trends are where? So some other. So choice depends on the budget, as well as the occasion where I am wearing. So these two are the weighted. These two are the features and how weights we are giving on. So with this real scenario, we apply the same thing to our techniques or our research problem. Our research problem, which feature predominantly gives the more weightage or gives the results efficiently. So, and most of the research algorithm pertain to the image processing, it comes from our real life. And one more thing, we always see ant. Wherever you keep the sugar, it finds the sugar. How tight you make the vessels, it will around the sugar. How? Ant knows where the sugar is. How? If you see the path of the ant, in our childhood days we usually play, right? If the ant goes, we slightly disturb the path of the ant. After some time, again it started going. If we again disturb the path of the ant, again it started going after some time. So somehow it finds the path for its destination. So viewing that, when optimization comes, it's called as the ant colony optimization. So most of the optimization techniques been evolved from the real time. You just go and read that. Those are all interesting. We always try to concentrate on the techniques, how the techniques been arrived. If you people just go and read out, that is interesting, or sometimes that made us laugh. We just go and read out. So that's an optimization which we can work it on. Next one is the geophysical image processing, particularly for the remote sensing. The people are working in the remote sensing, or people working in the synthetic aperture radar or radar imaging. They can go for they always work with the multispectral images or hyperspectral images. Those cases, what kind of the algorithm we can go on? So we can use that images. Next is video signal processing. Moreover, the video signal processing, we have to have some knowledge about color image processing. Whatever the algorithms, we try to find it out for the grayscale images, that's fit for the color images also. This statement is sometime right and sometime wrong. Sometime right and sometime wrong. Because all the algorithms, all the techniques are application dependent. For one algorithm which better suits for one kind of application need not to suit for all kind of applications. It might suit, it might not. So we have to evaluate, we have to choose an algorithm in such a way that it fits for all. Apart from the table, I try to say few applications, few fields that use DIP, which been categorized by the image sources, modalities. The image taken from the various modalities, we saw that 4 or 5 slides before. So from the image sources, what kind of the field it can be used. The first one is the image enhancement, one of the most common uses in digital image processing technique. This image enhancement improve the quality and remove the noise, etc. And the next one is the Hubble telescope. This is the electromagnetic spectrum involved. You can see the launched in 1990, the Hubble telescope. Last year also we come across the images which been scrolled on for more than a week. So telescope can take images of very distant object. However, an error or incorrect mirror made many Hubble's images useless. So we have to use image processing technique in such a way to fit what actually we want. Then the artistic effects. Nowadays we are very, very well versed after seeing Bahubali 1, 2, Aadhar, all those things. We know what actually the artifacts effects are working on in order to make the screen. And also we have a lot of app. A 50-year-old can make a 5-year-old kid. 5-year-old kid can make it a 50-year-old lady. All those things are happening in the app which we are playing with. The medicine, this medical imaging being tremendously, nowadays it's been tremendously using image processing, and lots of research is going on in medical imaging. Lots and lots of work on going on in medical imaging. This is one example I have shown here. Take slice from the MRI scan on canine heart and found boundaries between types of tissue. I am working in functional MRI. Few of my research scholars are working in functional MRI. They are working in 4-dimensional data. Next one is the geographical information system. Most of the civil students and geoinformatics students, remote sensing who are working, they know what is the impact of geographical information system. This geographical information system used extensively to manipulate the satellite imagery. Some we can try to classify the terrain classification, or we can use for meteorology. And the nighttime lights of the world data set, global inventory of the human settlement. Not hard to imagine the kind of analysis that might be done using this data. Next one is the industrial inspection. In the industrial inspection, what are the... Should I have to stop? Okay. Industrial inspection. Human, for example, if there is any defects in the PCB or any kind of industrial, human operators are expensive, slow and unreliable in some cases, not all cases. So make machines do this job instead. Industrial vision system are used in all kinds of industry. So for example, if there is any PCB defects, that can be inspected by the system, or is there any defects inside it or any crack in the tunnel, that those things can be inspected through the image processing. And the law enforcement, nowadays we can see lots of cameras all over the place where we are coming across. So image processing techniques are extensively used by law enforcers for recognizing number plates, for recognizing fingerprints, for recognizing face enhancement, for any kind of intruders coming into the restricted areas. All those things we can use image processing. And the next one is the human-computer interface. We try to interface between the human and the computer. Thereby, we can do lots and lots of work. So, what are the fields, or where are the digital image processing being used? That we have seen so far. I thought I can give some organization or vendors or company working in the field of image processing. As I said, it gives two things to us. One is to which source we can get what kind of the images for our application. That is one thing. Second thing, if you have an idea of to get into those kind of the companies, what are the eligibility criteria you have to learn or you have to enrich, that you can get in. So for these two things, I have put this slide. Organization or the vendors or the company in the field of image processing. First one is the Adobe system. We are using Adobe. I think everyone here have used Adobe in one form or the other form. This used for the image editing and the manipulation. And the second one is the NVIDIA Corporation. This NVIDIA Corporation used for the CPU, GPU accelerated image processing and deep learning application, as well as currently they are working, they have produced lots of FPGA boards also. So there we are, some of the image processing applications, we are using those FPGAs. Next is Google. Name of the product is TensorFlow, Google Cloud Vision API. They are producing both software and the hardware. This is widely used for image processing tasks in machine learning and deep learning projects. The next one is Intel Corporation, the Intel distribution of Open Vino Toolkit. This is in software. This, we can use it for image and video processing for computer vision application. And the next one is MathWorks. I think most of us know MathWorks. So MATLAB, the name of the products is MATLAB. There, especially, they are having an image processing toolbox. This toolbox we can use for image processing and computer vision application. And the next one is OpenCV, open source computer vision. The open source CV library. Nowadays we are using Python, where we are working related to all the image processing task. And the next one is the Cognex Corporation. The name of the product is Vision Pro. This one is the software and the hardware. Machine vision solutions for industrial image processing and automation can be done through this Vision Pro. The next one is MVT Software GMP Hutch. They produce, the name of the product is Halcon. This one is the software. Again, this we can use it for image processing and machine vision software for industrial applications. And the next one is the Basler AG. The Basler Cameras and Vision Systems is the name of the product. This is both, they have producing both the hardware and the software, which is used for the industrial image processing and computer vision solution. And the next one is DJI. Various drones equipped with image processing capabilities. This is the hardware product. Aerial and ground-based image and video capture for various industries. These are some of the organization whom they are working related to the image processing areas. And the Dynamic Ventas offers programming and software development services related to digital image processing, image analysis, image recognition, image enhancement, and computer vision. So this again, I thought I can give, apart from the company, I can give some few labs or few technical institutions which been working in the area of image processing. If you can see, first one is MIT Computer Science and Artificial Intelligence Laboratory. Here I have listed out few laboratories or few associations who are working in the area of image processing, and as well as what are the things they are doing related to the image processing task. So if we take MIT Computer Science and Artificial Intelligence Lab, they are developing research and development in computer vision, image processing, and artificial intelligence, and as well as Stanford Vision and Learning Library. Most of the universities, abroad university, they are exclusive having a laboratory which been exclusively working for the image processing. They are developing on both the software and as well as this hardware. So they are working related to research in computer vision, machine learning, and image processing. Max Planck Institute for Intelligent System Institute, they are working related to research in areas of computer vision, machine learning, and robotics. And IEEE Signal Processing Society, they are working advances in signal processing technologies, including image processing too. And NIST, National Institute of Standards and Technology, Image Processing Group. Their standards and research in image processing and computer vision, especially in the context of biometrics. So I have listed few association on few laboratories which been working in the image processing too. And this slides gives the various tools which we can work for related to the image processing. The very first one is the MATLAB. MATLAB is an organization which gives MathWorks, which is an organization which produces the MATLAB as a product. That MATLAB product we can use for various image processing application, and as well as the OpenCV, Adobe Photoshop, all we can use for image manipulation, image understanding, or image identification. Next one is GIMP. What is that? Is GNU Image Manipulation Program. This been developed by the GIMP development team. The operating system is Windows, Mac OS, and Linux, and it's an open source. With this, we can use image editing, photo retouching, graphic design, digital painting, patch processing, advanced features, plugin support being given by GIMP. And this again, ImageJ. ImageJ is the um, name of the tool. The vendor is a Warni Raspberry and operating system can be used in Windows, Mac OS, Linux, and it's a open source. This is especially used for biomedical image analysis, microscopy and scientific research, custom plugin, macro recording, visualization, and particle tracking. For this thing, we can use ImageJ. And the next one is Fiji, F-I-J-I, image distribution, given by ImageJ development team. And this been used for image processing and analysis, plugin integration, accessibility, scientific research, image visualization. And the next tool is Image Magic. Image Magic we can use for batch processing, format conversion, image editing, image composition, command line interface, web graphics design, and image analysis. And the next one is the SkyKit image. This has been developed by SkyKit image developers. It's again an open source tool. We can use it for image processing, feature extraction, image segmentation, image restoration, pattern recognition, quantitative analysis, and as well as the visualization. And the last one, as we talked about this earlier, it's a geographical information system, which helps us to better organize and understand spatial patterns and relationship taken from the satellite images. I have given only few tools. There are a lot more tools are there. Some of it exclusive for medical imaging, which we can work it for brain images alone. Few of my students are working in statistical parametric mapping. Few tools which exclusively work for the brain images. So there are specific tools which can apply for only specific applications or also there. This slides, I thought, as I said, we have to give a credit to the researcher or academician or a owner who have been developed or contribute to the area which we are working. I have listed few names who have contributed towards image processing. This can help you if you are interested in or if you are working in the area of image processing. You can go and search the paper by the author name or what kind of the work they have done. So the very first name is Thomas Shito Huang. He is no more now. He had given more than 21 books, 600 papers, and he published 1,300 research articles. He is the person who talk about the multimodal human-computer interaction and interface design. The very first he is the person who talk about it. The second one is Richard Sheasley. He gave the algorithms to automatically build 3D models for images and video. And Richard Hartley, the Australian National University, he belongs to. Most of his work based on artificial intelligence, computer vision, pattern recognition, and artificial neural network. And Sri K. Nair, most of his work related to computational imaging, computer vision, computer graphics, robotics, and human-computer interaction. And Trevor Derrill, he worked related to the AI, ML, and the DL. And David Forts, he worked in the area of computer vision, computer graphics, and machine learning. If we look into each of the researchers, they have worked in this particular area close to 2 decades or more than 2 decades. But the contribution by them towards this field is tremendous. For us, if we take 3 years to publish one article, in 2 decades, just a guess, they have published 432 research articles, out of which it's been 42,201 citation. So we can visualize how much contribution they have done towards the area of image processing, and as well as how depth the content would be. In a way, it being cited by close to 50,000. So the technique The application is real-time application. The technique, the novelty of the technique, that matters. That matters. That's distinguish each and individual researcher and their contribution go to any extent. This is again few researchers who've been working in the area of image processing. Currently, they all are working towards the AI, pattern recognition, machine vision, and robotics side. Um, this again Ramalingam Chellappa. He is currently working in Johns Hopkins University. He is working in multi-dimension stochastic process, statistical inference, computer vision and image analysis, robust and secure biometrics and AI in computer vision, and Fifi Lee and as well as Andrew Ng. They both contribute towards the image processing. The professor Fifi Lee is a professor at Stanford University, known for her work in computer vision, cognitive neuroscience. The person who are currently working in cognitive neuroscience, they should have a lots and lots of knowledge in order to work in the cognitive neuroscience and AI, and he is a co-founder of AI for All, a non-profit organization working to increase diversity in AI. And Andrew Ng, co-founder of Google Brain, former chief scientist in Baidu, and an expert in machine learning. He has contributed to various aspects of computer vision and online education. A few researcher and as well as their contribution towards the image processing. I have specifically put these slides in order to next I'll come to the current trends. Current trends, we always in the IoT, AI, DL, ML is the current trends, right? I hope this slide is visible to all. So I have listed a few AI in computer vision. In the segmentation side, in the classification side, as well as in the object detection side. In the segmentation, we all know AI is the huge and DL is the subset and subset of it is the ML. So machine learning algorithm for the segmentation, some of the techniques are k-means algorithm, improved k-means algorithm, fuzzy c-means algorithm we can use for segmentation. And as well as the deep learning algorithm, we all know CNN, RNN, lots of abbreviation come before, lot of letters come before NN. CNN, RNN, or CNN, all those things come. You can use any of it. Fully convolutional network, PSB net, conditional random field, all those DL algorithms are there for segmentation. These are all, again I'm telling, I'm giving you a little bit from the ocean. So this is not only the thing, this is limited edition, this is the limited. You can think of, you can use any kind of algorithms. So machine learning algorithms for classification, we can go for logistic regression, Navy Bayes, K nearest neighborhood algorithm, decision tree, support vector machine, and deep learning algorithm, you can go CNN, RNN, or long short-term memory, that is LSTM you can go, or by LSTM you can go, or CRF you can go. And for the object detection, the machine learning algorithms are sliding window algorithm, selective search algorithm, or Cadane's algorithm we can use for. And the deep learning algorithm for object detections currently in the research on fast region-based convolutional network, region-based convolutional neural network, single shot detection, spatial pyramid pooling, and ULO, that is you only look once. These are all few DL and the ML algorithm which we can currently use for image processing task. I think this is not visible, so let me talk with this. The point is, very first one is, what kind of application I'm going to work? That's the first question. The second question, that application in real time, where it is going to be used, who it's going to be used, whom are all going to be used those things. If these three questions is answerable, then we can choose what kind of the algorithm we have to go with, what kind of the classification we have to go with, what kind of the optimization technique we have to go with. There are n number of techniques for classification, n number of techniques for the deduction, n number of techniques for segmentation. So particularly for the specific application, what kind of the algorithm best suits, that's always, it's a trial and error. It can be a trial and error, or it can be an analytical, or it can be, we can design our own method, our own analytical solution we can give for those things. So entire image processing, if I comprise or if I put it in one line, either you have to enhance the image or you have to interpret the image. That's it. For enhancing, what are the things you are going to do? For interpreting, what are the things that you are going to do? That matters. So depending upon that, you can choose the algorithm, you can choose the techniques, you can implement the source tools. I can go for the open source tool, or I can go for the payable tools. That again, application dependent. Entire image processing task, image processing is the application dependent. And the last, usually we come across some of the sentences or word which always wander in our head, right? Recently, I read this. For the past 1 week, it's wandering in my mind. The way to succeed is to double your failure rate. This I particularly want to say to the researcher. Particularly want to say the researcher, because we always start with one end and we end with some other end. But what we achieve, that the matter. So the way to succeed is to double your failure rate. Thomson J. Watson, who is he? He's the first IBM chairman and the CEO. With this, I conclude my presentation. Now I request the audience to have, if you have questions, you can ask.
Good afternoon, ma'am.
Yeah.
I have a doubt, simple 3 basic questions. As I'm doing on traffic signal timing, I'm going to take an image of a road. One question is, I have many number of vehicles like cars, two-wheelers, etc. Can I like code or something like that, put the vehicle dimensions and count the vehicles from an image? Question number 1. And number 2 is, I have junk of queues in this heterogeneous traffic.
Junk of?
Queue for many number of vehicles are there. Like in foreign countries, we have separate, we can count the numbers easily. But in our scenario, we have mixed number of vehicles. So say for example, if you have 2 trucks, inside that you have a car truck or a two-wheeler or some other vehicle, we can't identify that vehicle. Say for example, 2 rows of big trucks are there and in between that vehicles are there. Can I detect that vehicle using image processing is my second question. And my third question is like, I'm going in for object detection. Which is the best tool like I can use? I know only MATLAB as of I know. Is there anything else like I can try on with?
Yeah. All the questions, we have answer in image processing. There are lots of tools for extracting the edges. Lots and lots of tools are there for extracting the edges alone. Currently, there are, we can go for the morphological operators, which extract the edges alone in the precise manner, and as well as counting the object in the queue. That also, there are lots of tools are there. Apart from the MATLAB, you can go for the OpenCV, which work towards your algorithm. That's why I given a lot of tools listed here. So there we have a solution. And the third question, what do you ask?
When vehicle?
Yeah, apart from the MATLAB, there are other tools also there. The thing is, all are application dependent.
Thank you, ma'am.
Is there any other question? Okay, before I conclude my presentation, I have taken some of the images from net. and some of the content from the Hanzolas, AKJ, and some of from the IEEE papers and Science Direct papers. I place my acknowledgement to all the person who have worked in the area of image processing. Apart from them, my research scholars helped me in some of the PPTs. So I place my thanks to them and I dedicate this presentation to my supervisor, Professor Dr. D. Ebenezer. With this, I conclude and thanks for all your patience, that too in the afternoon, without sleeping. I assume without sleeping you listen my speech. Thank you.
Thank you so much, ma'am, for your enthusiastic participation. And thank you for agreeing our invitation in the first time itself. Thank you, thanks a lot. Scholars know this particular topic we have chosen because this could be applied to any of your experiments, right? And your recent buzzwords like artificial intelligence, computer vision, all these takes into account the fundamentals of image processing. I think madam gave very nice inferences about the current state of art in image processing, and she also kind enough to tell us who are the researchers and what kind of a contribution they have made. So I think they should be the motivating factor for you, right? Thank you so much, ma'am. Please accept our token of love and appreciation, ma'am.
Actually, it's a pleasure to get something from him because he is my student. It's always a pleasure. It's always a pleasure for a teacher to receive some kind of a appreciation, some kind of a thing from a student. So I place my thanks to Gulam. He is the person who called me and asked me to give this presentation. Because of him only I accepted. And thanks to the research.